I'm Scott Philbin. Full disclosure, I have a company that we specialize in fuel quantity. But part of that component thing is that if some of you, have your own businesses, you become an expert in areas that you didn't really think you should be an expert in, just because of the passion you bring for, what you're doing and putting out there. And while I've been in aviation my entire life, I was here at Oshkosh when it wasn't Oshkosh. I lived in New London. I came down and worked with Steve Whitman and his cronies. I was an airport rat up at Appleton. I worked at Gulfstream in Appleton. And then I moved out west to work for a small company, Precise Flight, that did speed brakes. And I did flight test work there. And then I started my own company because Cirrus asked me, Scott, could you fix fuel quantity? You've done this and this for us. And I went, why don't you just tell the customers fuel quantity hasn't worked in aviation? And that didn't go over. They said, no, these guys are spending $1 million on an airplane. They want everything to work. And I was like, well, all right, we'll give it a shot. So that's my background. And if you feel like I'm stepping over into ground where I'm selling something, that's not my intention. So let's start out with the words we all hear is don't trust your fuel gauges, right? That's the 5 most dangerous words that I hear in aviation, and I'll tell you why. The other thing you hear is they only have to be accurate at 0. And so, the funny story is you're flying along in your airplane, your engine starts sputtering, you've got nothing below you but crappy fields and rocks and trees, and it's like, oh geez, bad news is I ran out of fuel. Geez, the landing conditions don't look very good. But on the bright side, my fuel gauge is accurate. If we really wanted to have a fuel gauge that would give us some sense of warning, we should say they only have to be accurate at 5 gallons, right? If we were really interested in it, because at 5 gallons a side, we'd be able to decide where we were able to land. We could make decisions about where that would be, and most likely it would be at an airport. So even if at the minimum, if the FAA or if that particular statement were true, accurate at 5 gallons is a much more safe standpoint. Who cares at 0? There's a bunch of things in the airplane that tell you that you're at 0 fuel. So I wanted to look at, particular accidents, because one of the first things that my dad told me, and again, I've been in aviation a long time, I had to polish Bob Hoover's airplane at some point in my life because my dad was an aero commander. He went to school on them and he was very familiar with them. But I just lost where I was at, but I'll get there. That component part, has been part of our aviation. It's what we live with. So that we talk about this accident, and unfortunately, like a lot of accidents, they involve, the loss of human life. So the accident I'm gonna utilize and work on, and if you indulge me, I was gonna show the video that AOPA put forth, is the accident in Kerrville. It was a Baron 58 pilot. He was a pro pilot. He was operating a surreptitious 135 operation, so he's operating on the questionable level of what he's doing. He's filled the airplane a week before, and there's some controversy because the FBO says, oh, they definitely filled to the top, and that's really becomes an immaterial when we start talking. He makes 5 flights. He keeps a very careful log of each of the flights and the amount of fuel burned. He takes his final flight, and they're going from West Houston to Kerrville to look at some property, I guess, in Hunt, Texas. So right away, they evaluate, what he did in the aircraft pre-flight, and they said it was brief. But if you know something about the Baron 58, at 34 gallons a side, or what he had 58 gallons total, 25 and 4, 29 gallons a side. There's no way you can look in the fuel filler and see that level. And convenient for beach Baron owners who have 58s, you have a sight gauge that's on top of the wing, and you could cursorily walk by and see what you had. I will tell you that most Baron owners don't trust that visual gauge very well. Me and my flight test work, I would thump the bottom of the airplane wing to where I thought the fuel should be. Then I weighed the airplane. Dead plants and animals turning into noise. So you're pretty fastidious about establishing a pre-flight fuel state. But what you should also do, and what every POH tells you, is that once you've pre-flighted the aircraft, you confirm the fuel level on the gauges. And in this particular case, after evaluating the gauges, the aircraft showed an artificially 10 gallons more than he actually had on board. Okay? So he's already short, in this particular case, the required fuel to make the flight he has, but barely short. But what he doesn't know is he's 10 gallons below that. And here's a place, I'd put up a fish diagram and where we would get to where we could break the accident chain, but an accurate fuel gauge when he climbed into the aircraft would have given him that. And we'll talk about that further as we get into his accident scenario. So he takes off and has an IFR flight plan, but he has to file an IFR approach into Kerrville. At the point that he's flying over the Kerrville airport, because this waypoint is beyond Kerrville, if his fuel gauges met what we establish as a requirement, they would have read 0 as he's crossing the airport threshold before he flies 20 miles in the opposite direction. He could have made it with accurate fuel level, he could have broken that accident chain. I'll have to ask for another time other than 4 o'clock. So he could have broken that accident chain at that point. He makes the turn. At that point, he's run out of fuel, and he tries to restart the engine, and he makes multiple other errors. He doesn't feather the prop on the unstarted engine. He leaves the flaps down, and the airplane's dirty. He, like a lot of us, he wants to preserve altitude over airspeed, which doesn't work, and then the airplane pancakes to the ground. So it's a tragedy. But let's talk about, they evaluate his wreckage, and for the first time, I hear it coming, but for the first time they actually evaluate the fuel system. I know they're coming back. And that was something that I lobbied heavily for when on the Navajo accident down in Florida and Georgia, that they left fuel in the airplane in the auxiliary tank that would have made the flight. So it's a bad accident scenario, but you evaluate the fuel gauges and they read 10 gallons high. So at 0 fuel, he's reading 10 gallons extra in his fuel tanks, 5 gallons a side. So he would have seen that, though, when you think about it. He made multiple trips in this airplane. He's had this airplane for a long period of time. He would have known long ahead of this flight that his fuel gauges were off. So there was no point in believing what he had. He had no correlation between his fuel gauges and his fuel totalizer, which is the device he used to register that. And fuel totalizers will lead you astray because they represent accuracy by precision, but the opposite isn't true. If you don't have the right starting number, you can be deceived into believing you had fuel. And perfectly to his seeing, he was fighting another problem other than fuel, even though it would seem obvious, because there was an indication that he still had range available in what he was doing. And he was immaterial what his fuel gauges were reporting to him at that time. So when you get down to, I expect them to come back. So Canada has found this to be true, that in accident investigations that they do, that 90% of the aircraft that they evaluate have bad fuel indications, that suffer fuel starvation, exhaustion events. Australia found that to be true as well, and Australia doesn't have the benefit that we do of having airports every visual reference, as far as we can see. And Australia requires people to actually calibrate their fuel gauge, like their airspeed, every 4 years. So what was the net result of that? Or what's the net result of having accurate fuel level? Because here's a situation, you could break the accident chain anywhere along that piece. Well, Cessna went to a more modern fuel quantity indication in 2008. It's a time domain reflectometry. I can get it out before he goes by. Which is shoot a signal down a coax cable and measure the response from the end and the response where fuel impinges on it, and they measure it a millionth times of a second. It's what they find in a 172, 182, 206 Caravan. Expensive system, but very accurate. And then we have our system, which we've installed in Cirrus's since 2012. So in both of those cases, and then we could include Diamond, which has a capacitive system that's accurate, there's been zero fuel starvation, exhaustion, or accidents for the whole fleet. What's more impactful, because we know this data, we have 70,000 fuel senders in the field, we've had zero fuel incidents and accidents. And if you fix or repair your fuel gauge, again, this is the most notorious gauge in the cockpit. This is the gauge you're not supposed to trust. This is the gauge you're not supposed to evaluate. But actually having a functional working gauge, and any system can be made functional, you don't have to come to us. Just a little bit of effort and time to make sure things are clean. You can actually have something that would be critical in preventing a future incident or accident. And we're living proof that if you have accurate indication, pilots make better decisions. So with that, I'm open for questions. Anybody? Yeah. Anyone? Yeah. I don't know if I have anybody, but I can come down there. Yeah. Oh, all right. So that's a good question. So the question is that the gauge has to be accurate at empty. So, and I've done this flight test work, so I'm intimately involved in it. So the requirement is that the gauge reads from the zero fuel level to full. And then the second part of that notorious document says where the zero fuel level is established by a test, and the test consists of a full ball approach, usually flown at 8,000 feet, a full ball off slip approach to landing, and you can't unport the fuel quantity so that you have an engine hesitation. So that's where you get that, that's where zero fuel comes from. And so what they're doing is saying, okay, that's your zero fuel level. You get to read from there to full accurately. And when you're doing aircraft certification work and you use Advisory Circular 2317, their requirement within the advisory circular is to be within 3% through that whole value. So on a typical GA aircraft, you're talking about a gallon off, gallon and a half, which will surprise most people, but if you actually look in the maintenance manual for the individual aircraft that you own, and you look at for fuel calibration, you'll be surprised at how accurate they want you to be. If you read, let's just take Piper Cherokee, for example. They want you to be a quarter needle off of the actual value is all they allow. And you read that, and then they have a whole test rig setup that you're supposed to put your fuel sender on and match that to a specified resistance. And and my dad's been a mechanic IA for as long as I remember, and I'm old. He's never done that. Yeah, and he doesn't know anybody who has. But the information is there, but we've somehow, like as a group, decided that this gauge doesn't have any value in aviation. And we've let those things slide. But every aircraft manufacturer has a required service bulletin that you're supposed to fix the fuel gauge. And it could be a cover your posterior component part, but Cessna has a very comprehensive service bulletin that says, mandatory, that your fuel gauge should be calibrated in a timely manner when it's found to be inaccurate. Any other questions? Yeah. Yeah. Okay, so the question is, if you want to put something more modern in the aircraft, like ours, Electronics International makes a similar unit, similar technology. What does it take to retrofit into the aircraft? So when we designed ours, and I believe when Electronics International designed theirs, we picked a design that matched the fuel senders that you would be typical to looking at. They're float-based sensors. And in both cases, we took out the part that measured the fuel, the potentiometer, which is just a follower on a wire of resistance wire, and different resistances where the follower is represent a different fuel level. We use a magnetic pickup that works more like a magnet, in both cases, works more like a magnetometer, and north is exactly your float. So it's just pointing, it's a compass pointing to the float. So to do that, it's an active sensor. It's not a passive like the resistance of a legacy fuel indication. So you now have to add a power wire out, and you have to have a ground or a good ground. So the good ground could be the airframe, but in some cases it isn't. And then you have to have the signal wire coming back. When EI designed their system, it only goes to EI gauges. When we designed our system, we actually made it universal. I could actually report out to an existing fuel gauge. But the FAA was interested in this, and they said, we want modern fuel indication to look like modern fuel indication. So you have to swap out your instrumentation in order to achieve it. It's not, if you want to do a 337, we can show you how, but I'll guarantee you when we show you how, you're better off putting new indication in. It's just easier. So we report out, and most of the business that we have are people retrofitting into Garmin panels, G3X touches, JPI, 900, 930 systems, EI, CGR 30s, and MVPs. So it really belongs with something. And I think that if you tie, and this is this is my observation, if you tie your totalizer and your fuel indication together, as JPI has done and Garmin has done, That's super insurance that you've got the right information. And in both cases, I've lobbied them to have a mismatch warning. So if you inadvertently hit, I filled the tabs, or I inadvertently hit to full, and that's not what happened, or you have a maintenance-induced failure where you're pouring fuel overboard, or a pilot-induced failure, you didn't put the cap on, you have indication, because they'll say it's a mismatch. You don't have, the totalizer's operating correctly. It's measuring fuel that's going into the engine, but something else is consuming it, so now you have a problem. Similar thing that happens, bladders and bonanzas and barons will suck up if the vent's not wrong, but you'll have an indication you got a problem. So this steps over on more on the marketing, but we don't build gauges, but we recommend at the small level Aerospace Logic. They're a Canadian company. They build a 2 1/4 inch gauge. It's got vertical bars. If you have an aircraft with multiple fuel tanks, like a Comanche would be a good example, or an Aztec in that same realm, or a Cessna Twin, you can put all of your fuel indication on one gauge, where prior to that you had to turn the fuel selector to that tank to determine how much is in it. That's an old concept that came about by trying to minimize the number of gauges you had in the cockpit. But think about it. I'm going to turn to an empty tank with my fuel selector to see how much fuel is in it, or do I just want to look on a graph and see that there's fuel there and then turn my selector to that tank? It's proven out. It's one of those things, like Blanca Vikings are well known as fuel starvation aircraft because they have 6 tanks or 5 tanks depending, and nobody knows where the fuel is. It's like button. The engine stopped, and mentally, at least in my case, when I came close, I had the wherewithal and training. I just went and switched tanks, problem solved. But which tank do I switch to when I've got 5 or 6? Any other questions? Yes. Yeah.
One of the gauges, I know that.
Yeah.
Talk about the calibration. How much time does that take?
Okay. Yeah. So the question. So the question is, that's a good question, and I know it really well. So on the Piper Cherokee, the question is, how long does it take to actually go through the process? Well, all Cherokee owners know that they were under an AD to have the spar looked at, so the tank has to come off. On a Cherokee, the tank sender is mounted on the backside, and unlike its bigger brothers, Piper chose not to put an access panel for the sender. So to get to it, the tank has to come off. And actually in the AD, for the wing spar inspection, they said that you should check and calibrate the fuel sender. I've yet to talk to someone who had that done yet, and check the security. But so, about an hour by the time you shipped all the paint and got the tank out. That would say it'd take another 2 hours to calibrate it. Now there's a deal about Cherokees because they're also they're a very popular aircraft, so it's hard to equate this, but they also suffer a lot of fuel starvation accidents. And that's another little point to talk about. Within the Cherokee design for the fuel tank, there's a stringer. If you don't get the fuel rod with the float bent in the proper position, that fuel gauge will never read 0. It'll read 5 gallons at the bottom because the float will rest on that stringer. And I've seen several accident situations and actually talked to a pilot, another Texas aircraft beautiful Cherokee. Like this guy was an interesting. It was a good story. The guy is a C-130 master technician, or no, he's not the technician, he's the flight engineer. He's the guy who goes around the world, or did in his career, goes around the world to teach C-130 flight engineers how to manage the 4 engines in a C-130, and do so in a very precise and orderly format. Because I was looking at his NTSB report, and I'm like, there's something really weird about this. He's making every hourly flight pass an airport where he's making a decision. Like, it's weird. His flight plan it's not straight, and it's not zigzag. It has slight deviation, so he makes hourly decisions about go, no-go situations very close to an airport. This is like a pilot you want to fly with, because you know. You know, pre-flighted his aircraft, I talked to him. He went flying. Long leg, it was a 5-hour flight in a Cherokee. It can be done. Gets to his destination at what are the beaches down in southern Texas, the barrier islands, Padre Island. And the aircraft starts to sputter about 5 miles out. He has his brand new son-in-law on board, knowing that his daughter would kill him if he did something, makes a turn and lands next to the airport, but didn't think that he would be able to make the fence and didn't want to flip the airplane over. He comes down to it, and he doesn't know. The FAA and NTSB go, oh, you're bad, even though you have your flight plan, poor flight planning, da-da-da-da-da. But no one ever looked at his gauges. I have another example where I saw it, where another guy who was one of those facilities, he was running a flight school in central Indiana, ex-military guy, pre-flighted his airplane in front of people, Cherokee, flew it, landed in a tree on approach to the runway. He has no memory, but they did take his fuel senders out and set them there and took the tanks out, and that's where I saw that problem. It was sitting on there showing that he had 5 gallons of fuel left. But I don't know where the fuel went. He was maybe enriched, maybe, but it wasn't the kind of pilot that you would say, hey, this is a fuel-starved kind of guy. These guys were like, by the numbers, by the letters, do everything right. And that's the interesting thing, is I processed all this information. You're more likely to be a fuel starvation or exhaustion statistic if you're an ATP, commercial pilot, CFI, or CFI2. 50% of the accidents occur to those pilots, and you all know that they represent about 25% of the pilot population. It's an interesting statistic. It isn't the sort of deal, because it's pilot stigmata to have a fuel starvation accident. You don't want to be running around with bloody hands, but it's actually occurs more than you would imagine and closer than what you imagine, but it occurs to pilots that you wouldn't attribute it to. And we hear that, Daniel here, and I hear that all the time. We hear from people where, their engine quit on the taxiway with their family in the airplane. They'll call us up and they'll go, that can never happen again. That's one, I'm not going to be able to fly, and with my family, and anything else that goes with it. And like every pilot, they'll swear up and down, I checked my fuel before I went. I did all of these things. Just all those conditions conspired to make a situation that could have been prevented had they had accurate fuel indication. But once you have the tanks off, it would be about an hour to calibrate it. It would probably take you about 4 hours to get some kid with a 3D printer to actually print you the jig they want. But we live in the modern world now. Before you would have to fabricate, you'd be on a bandsaw cutting things, putting screws in it. Now you could take that design, put it on a 3D printer, and you'd be done with it in a day. But once you had the jig, you'd be all set. Any other questions? Yeah. Okay. So the question is, how do you handle fuel indication, when the aircraft's not level? The weird thing about aircraft is they're symmetrical, and I know this because I would have asked that same question. Whatever you gain on one side, you lose on the other in a properly calibrated system. The Koreans, we had an accident in Cirrus. It wasn't due to fuel exhaustion, it was fuel contamination, but the aircraft landed, or it didn't land. The aircraft set down because it came down under parachute on a slope. And they were going, well, your fuel indication read this on this end and this on this end, but strangely they added together to be the exact fuel we drained from the aircraft. That holds true. So that gives you a good starting value if you stick the tanks, beforehand, if you can stick the tanks. There's a lot of, and I could have been accused of this before. I have taken off overgrowths just so that I knew that I had a fuel state that I was confident in. I can say that out loud, but I have. Before I did all this, when I was living, and I didn't care. I mean, I was like any pilot that gets in a Cessna. That's the fuel gauge. I hope, I hope I don't have to rely on it. I never thought about it after. It's like, I got my watch. Never had a totalizer on an airplane when I was flying it that I used. So, any other questions? Yeah. Yeah. Okay. So the question is, I bought a fuel monitor, and I did a comprehensive one. I got a totalizer that also has the capability of measuring fuel quantity. So when I probably didn't give the example. So we had wire wound resistor. I have a follower that touches that resistor, and it moves as I move the float up and down. And the idea of the float having buoyancy is really not, it's strangely, because I thought it was true, really the float has to have enough weight to sit back on the fuel as it slowly drops underneath it. So a heavy float is not the worst thing in the world. It's actually beneficial. But when you pair up a modern instrumentation with this analog signal, there's three things that happen. One, avgas and water form a corrosion compound. Aircraft, because we don't fly every day, unfortunately, have high latency, so they sit there in a corrosion environment. Same thing's true in boats. The other more insidious thing is that the fuel senders that were designed for aircraft are the same that they use in tractors and heavy equipment. They're designed for about a 10-year life, but unlike tractors and heavy equipment, we get a lot of lateral movement of fuel, especially when you taxi. So it tends to where the pivot is on those senders. So when you wear the pivot is a critical component for accurate contact with that resistance wire. And when it starts moving away, it starts Morse coding. And the Morse coding on an analog gauge is your windshield wiper effect. On the JPI, it's inaccuracy. Or your aircraft is tied down outside and is buffeted by wind. All the time, it's sitting there and moving up and down on that resistance grid, wearing it away. We see, just for fun, when people send us senders, because we ask for them, we look at that and we can see those patterns. Oh, this airplane, the guy filled it all the time, but not quite. So an expansion in the sun because the top is worn out. Or this must be a flight school because they left the things pretty empty at the end of the day and parked them before somebody came around. Somebody came around in the morning and filled them up prior to the students showing up. It's funny when you look at the characteristics. I can tell exactly what, how the aircraft was treated or what. Or this had high latency. I've seen things taken out of airworthy aircraft that look like they came from the Titanic. There's rust sickles hanging down on them. Because another component of using heavy equipment fuel senders or automotive fuel senders is that they were made of steel, and then we combined them with aluminum, then we put them in a corrosion environment, then we decided to use them for 30 years. And when you say that, it just goes, oh, that's why fuel indication doesn't work in airplanes. So to fix that, you either have to get new senders in a resistance format or go to something like what we produce. And where we have a digital signal, it doesn't matter if there's dithering, we're always putting a signal to the device. And that's been true with Garmin as well. It's hard to match an analog instrument that an analog sensor, can report to a gauge and you only see minor variation. But